Hey Nicholas, welcome to class. For today's lesson plan, we're going to go over four main things. First thing is reviewing different factoring techniques. Then we're going to talk about quadratic formula, how to derive it, which basically means how to, create it from scratch. And then, do some practice work with quadratic formula. So first thing, let's look at some of the factoring techniques that we've covered so far. So number one, we can call this just, basic factoring. This is where, you have things like, 4x squared plus 2x equals 0, right? Well, looking at this, you can immediately see factor out a 2 and an x, so it's 2x times 2x plus 1 equals 0, right? And so you just take out a common factor. That's the most basic factoring technique. So we can call this common factor factoring, right? And then from there you just either this is 0 or this is 0. Basic stuff, right? So the second thing on our list is going to be sort of the split factoring, right? That's something like x squared plus 5x plus 4 equals 0, right? And you ask yourself, okay, what are the factors of 4 that add up to 5? Well, 1 and 4. So we know that this would just be x plus 1 times x plus 4 equals 0. And then, of course, x is negative 1, x is negative 4, and that's it. So this is sort of your basic split factoring. Then after that, we learned about a little bit more complicated versions, right? So we learned, every quadratic has this form, ax squared plus bx plus c equals 0. We learned that there's different situations, right? There's like where b equals 1, where b equals 0, and then that means you just have ax squared plus c equals 0. Well, that's pretty straightforward, right? If I have something like x squared minus 9 equals 0, then I just can add 9 to both sides. X squared equals 9, take the square root, and get x is equal to plus or minus 3. And I'm done. So that's pretty straightforward. You just move c to the other side, and if there's an a, then you just divide both sides by a, and you take the square root. So those are pretty straightforward. B is equal to 0. The other situation is when c is equal to 0, right? So when c is 0, that's just ax squared plus bx equals 0. Does that sound familiar? It should, right? That's very similar to our basic factoring case where you just pull out the x, right, the common factor. And so there's nothing really too special about that. It might look like x squared plus, let's say, 7x equals 0. Well, factor out an x. You get x times x plus 7 is 0. Again, simple solution, right? X is 0, x is negative 7. Easy, easy. Then after that, we talked about the harder case, which is when, right, a, b, and c are all not equal to 0. So you have a full-on, something like x squared plus, let's say, 10x minus 8, right, equals 0. What do we do with this? Well, we can't do basic factoring because the factors of 8 are 1 and 8, 2 and 4. Those don't add up to a 10. So that's not going to work. So this is when we learned about completing the square. And so completing the square, remember, what do? We take the b term, divide it by 2, and square it. And then that's going to be what we're going to add to both sides. But first we move that negative 8 over. So let's put this in our pocket over here. So we add 8 to both sides, and we would get x squared plus 10x equals 8. Then we go ahead and take 10 over 2, which is 5, squared is 25, and add 25 to both sides. Then this just becomes, remember, this number divided by 2 squared. So x plus 10 divided by 2 is 5 squared equals 33. And then you square root both sides like before. x plus 5 is equal to the plus or minus square root of 33, and then just subtract 5 from both sides and we have our answer. X is equal to plus or minus root 33 minus 5, and we're done. So that's completing the square, right? And then we also learned an extra method that's a little clever. We learned AC method. So actually, why don't we do this? Why don't we call this method number 5? Actually, we'll leave it as number 4, but completing the square is actually method number 5 that we learned. So I'm going to take this, shrink it down a bit, put it down here, and this is going to be method number 5. Method number 4 was AC method. And if you recall, that was the method that we used when the leading coefficient was not equal to 1, right? So let's look at an example where the leading coefficient is not equal to 1. So that might be something like, let me see, let's find a quick example here. I'll pull up an old factoring worksheet. So let's try this one, 5x squared plus 19x plus 12. So 5x squared plus 19x plus 12 equals 0. So AC method, right? Remember it's called AC method because you take the A term and the C term and you multiply them together as your first step. So that would be 5 and 12. So 5 times 12 gives us 60. And we think of the factors of 60 that add up to 19, right? So 1 and 60, 2 and 30, 3 and 10, 4 and 15. There we go, 4 and 15. And then we split the middle number up into those two factors. So we have 5x squared plus 4x plus 15x plus 12, right? And then you factor the left and you factor the right. So we can only take an x out of here, so that would be x times 5x plus 4. And over here we can factor out a 3. So that'll be 3 times, well, surprise, surprise, 5x plus 4. And then once we have the first factoring, we factor again, take out that 5x plus 4, and then we take what's left over, the x plus 3. And that equals 0, and then we just solve that like normal, right? Either this is 0 or this is 0. And we would be able to solve our problem. And then last but not least, we have our favorite method, completing a square. And so those are the basic factoring techniques for dealing with quadratic equations, but there's one final method or formula that we use that works on any quadratic equation, and that is known as quadratic formula. So, of course, I'm not going to be a pushover and just give you the formula, because I want you to actually think about it for a second, right? So every quadratic that we're going to deal with looks like this, right? ax squared plus bx plus c equals 0. Ask yourself, how can we take this general equation, right? This is we call this the standard form, because this is the most basic standard form that you'll see for a quadratic. How can we take this and maybe create a formula that will work for any quadratic, right? We want a formula that works for any quadratic. Well, what method do we know that has been working for any quadratic? I think that would be completing a square. So maybe, just maybe, we can try to complete the square on this, even though we don't know what A, B, and C are. And so that's what I want you to try. So I'm going to give you, let's say, 10 minutes, starting now, and I want you to try to think of a way to deal with this and make it to where you can complete the square and create a formula. So go ahead and pause the video for now, and I want you to try to work on that and figure that out. Now don't just hit play and skip. This is important, right? I want you to actually take the time to practice and see if you can figure it out. It's like a challenge. And then, of course, if you get an answer, you can always hit play and check it. Or if you get stuck, after the full 10 minutes, feel free to play the video, and then I'm going to go ahead and explain how to do it now. Okay. Alright, Jeopardy music over. So, hopefully by now, you've figured out the formula, but if not, let's try to figure it out. So, what method are we using? Completing the square. How do we complete the square? Well, we take the b term, we divide it by 2, and we square it and we add it to both sides. But first we need to move the c term over. So let's say we have ax squared plus bx equals negative c. Alright, move that c over, minus c minus c. Okay, so now that we move that over, we're going to have just ax squared plus bx equals negative c. Well, what's our next step? Well, notice this x has something in front of it. We like x to be by itself. So what's our next step? Divide everything by a. So you divided by a, you get divided by a, and you get divided by a. Then that just becomes x squared plus b over ax. Oops, sorry, just trying to move this down a little bit. Equals negative c over a. Looks gross, but it is what it is, right? And what's our next step? Remember, we take this middle term here, this b term, and we're going to divide it by 2 and square it. So we're going to do b over a divided by 2 just means multiply by a half, right? So that's just basically b over 2a, and then we're going to square that. And we're going to add that to both sides. So plus b over 2a squared plus b over 2a squared. Now that we have that, we can finish completing the square on the left side. So this is just going to become x plus, remember what the rule is, right? It's just this number divided by 2 is going to be what's going to be down here. So just b over 2a. Oh, sorry, 1 second. Right, so b over 2a squared. And that's going to equal this lovely monstrosity over here, right? Negative c over a plus b over 2a squared. Well, now that we have this, we know how we get x. We need to square root both sides. And that gives us x plus b over 2a equals the plus or minus root of all of this crazy looking junk over here. Why are we trying to do this, right? Well, somebody figured this out, and it's made math a lot easier for lots of students, and we want to try to do the same, right? So we have x plus b over 2a equals plus or minus blah, 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 blah. Well, we want to get rid of this b over 2a, so let's subtract it from both sides. So we get x equals negative b over 2a plus or minus the square root of negative c over a plus b over 2a squared. Yikes. So from here, we have our solution. This is the quadratic formula, but it looks horrible. So our question is, can we simplify this a little bit, make it look a little neater, right? Clean it up a little bit. So the first thing I'll notice is that I can actually expand this b over 2a squared. It just becomes b squared over 4a. So why don't I do that? Okay, oh, well, this has a and this has 4a. If I want to add these fractions, I need a common denominator. So why don't I multiply this by 4 over 4? Now I can combine these two fractions and it just becomes negative 4c plus b squared. Or if I flip it around, b squared minus 4c over 4a. And we still have plus or minus negative b over 2a. Well, 4 is a perfect square. Why don't I take that out of the square root? So what's the square root of 1 over 4? 1 over 2. So this becomes, and we'll take a break because that's going to be the end of this first video.